Well, well, it's so looking so beautiful, and we have this question that we were talking about during the course of the week. So we decided to give it a try and see the best way to go about it. This particular question is using using trick identity metrics or using trick identities, and there's MIT integration BEE13. The question says cos 4x cos 4x plus 1 divided by cotangent of x minus tangent of x dx. And we need to resolve this. So, it's looking so beautiful. And it says using trig identities. So let's see the best way to go about this. Well, without further delay, let's set the ball rolling. Okay, so let's look at this from this perspective. So the question says, let's go to drawing and we write. It says, of course, for x plus 1 all over the cotangent of x minus tan x, okay, dx. All right. Well, I don't know the reason why this pen is behaving this way. So, if we look at this question, to me, what comes into my mind is, since I've seen cos 4x, okay, then I know I can break it down using the trigonometry properties, because I know that if I have cos 2 theta is given as 2 cos squared theta minus 1. You see, 2 cos squared theta minus 1. If you've been doing trigonometry over the years, then you will know that this is normally given as cos squared theta minus 1. The reason is that if I have, let me use this one. If I have cos 2 theta, then it means cos 2 theta means cos theta minus sine theta, the sine theta. And this, straightforward, we all know that this will be cos squared theta minus sine squared theta. Well, and also, we also know that cos squared theta plus sine squared theta is always equals to 1. So with this, we can say that sine squared theta is equals to 1 minus cos squared theta. Over the years, this is what we used to do. So when we substitute this into the equation cos squared theta, so then now cos 2 theta will be equals to cos squared theta minus all this 1 minus cos squared theta cos squared theta. Okay, so this gives us 2 cos squared theta minus 1. Well, so this very simple trigonometry properties can help us break down something now, because we can see that if we have cos 2 theta to be equals to 2 cos squared theta minus 1, okay, then that can make life easier. So if I see cos 4 theta, then cos 4 theta from the equation, from the equation, or from the integral, sorry, from the integral, given, we have cos 4 theta, oh sorry, cos 4x, we have cos 4x, plus 1 as a numerator. So then, since cos 2 theta, so I say cos 2x give 2 cos squared x minus 1. Then I can say that cos 4x will give me 2 cos squared 2x minus 1. So then we can substitute this into the equation. So let's see the best way we can do that. So with our integral, which is the integral cos 4x plus 1 all over cotangent of x minus tangent of x dx can be written as 2 cos squared 2x minus 1, okay, plus 1. The integral of that all over cotangent of x minus tangent of x dx. So the simplified form of this, then we can say that 2 cos squared 2x, because 1 will cancel 1, so this will be cotangent of x minus tan x dx. The integral of that. Well, are we making headway? Somebody will say, well, we're getting there. Why? Because cotangent means 1 over tan. So let's see. So if we have our so 2 cos squared 2x all over 1 over tan of x minus tan of x, because the cotangent is 1 over tan dx. Then can we write this one this way? Yeah. Then when we multiply through by tan x, okay, when we multiply through by tan x, our equation will be 2 cos 2x tan x dx, the integral of that all over 1 minus tan squared x, which we know that 1 minus tan squared x will give us sec squared x. This is sec squared x. So in a nutshell, this integration, we can say that it is 2 cos 2x tan x all over sec squared x. Wow. Are we getting anywhere closer? Well, I don't think so. I don't think so at all. So that is the reason why I always say that if you have integration, you must always critically analyze it thoroughly before you set your ball rolling. As in examination condition, you'll be so compressed in your mind in such a way that maybe you may refuse, the brain will refuse to think. So now, this will make it more complicated, yeah, or lengthy, yeah, lengthy way of solving the question. So now, let's see if we can break it down in this way. Okay, now, now, you see, it's looking so nice. But what I'm gonna do is I'm gonna break it in this different way. Let's go back, okay, because definitely we know the question actually says 2 cos squared 2x dx all over sec squared cotangent squared cotangent x minus how do I call it, tan x, the integral of that. Okay, now why don't we try and break it down, because we know that the integral will become 2 cos squared 2x dx all over, we know cotangent is given as cos x minus cos x over sin x. Our cotangent, okay, is cos x over sin x minus our tan is sin x cos x. Okay, with the denominator, let's have a look at it. And let's put our integral here once again. So the integral of 2 cos squared 2x dx over cos x over sin x, okay, minus sin x over cos x. Alright, so this is the integral, but if you we'll do a deeper observation, okay, so this with the actual integral. So what do? Why don't we multiply this by 1? Because you and I know that if we multiply the denominator by a certain value, we have to do the same to the numerator and vice versa. So if I say let multiply both by sin x cos x, okay, when we do that, when I say this sin x cos x, okay, when I divide this by that, I get 1. So it's just like 1 multiplying the equation by 1. So I'm going to make this one in blue. Let's see. So if I multiply the top one by sin x cos x divided by sin s cos x, Okay, with all due respect, you will see that when we do that, okay, sine, okay, sine here, let me use different, sine x here will cancel the sine, okay, and this cos here will cancel this cos. Okay, so let's see. It will multiply. So the top one will be the integral of 2 cos squared 2x sine x cos x dx. Okay, all divided by, okay, so this one, the bottom one, is going to be cos squared x minus sine squared x. Ooh la la. So this is the breakable pillar that we have now. So now, let's look at this. If you look at it very carefully, you will see that if the bottom one is the same as we calling this cos 2x, because we know that cos squared x minus sine squared x is cos 2x, as we saw earlier. So this one will come here to okay. Now, after that, our integral, okay, let me clean this one. After that, our integral sign, okay, we know that the top one, we can say that cos squared 2x multiplying 2 sine x cos x into bracket dx all over cos 2x. Beautifully. So, if we look at it very, 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 very well, we will see that this one, which is this, the top one, we can say that sine x cos x can be written as sine 2x. So therefore we can substitute that one on top, so that then the numerator has also helped us. So we can get the integral. So our cos squared 2x will be multiplied by, and you see we have this cos 2x, and I'll bring our sine 2x here. So this is sine 2x. Isn't that beautiful? Sine 2x. Okay. Down. Sine 2x. So our equation is now becoming very beautiful. What can we do? We realize that this one, this cos 2x will cancel cos 2x, one of them. So if that will be the case, okay, see, this will cancel this by 1. Yeah, cancel 1 So we left with the integral cos 2x sine 2x dx. Wow, beautiful. So what comes into mind? What comes into mind if we manage to solve the equation? Now let's look at it. This integral, so our integral is now integral cos 2x and sine 2x dx. But recap. We know that sine if we have cos, if we have let me clean this one. If you have okay, good. If we have a sine 2x to give us 2 sine s cos x, then we can say that sine 4x will give us 2 sine 2x and a cos of 2x, which is similar to this equation we have over here. So therefore, for this one to stand alone, okay, for this one to stand alone, we'll make it a subject, so that our equation now will become that sine 2x cos 2x is equals to 1 over sine 4x. Beautiful. So in the substitution, since we know that sine 2x cos 2x is 1 over sine 4x, then our integral will be half integral sine 4x dx eventually. And when we integrate this, you see it will be minus half out times 1 over 4 cos of 4x plus c. So in effect, the answer will be minus 1 over 8 cos 4x plus c. That's the integral. Okay? So isn't that wonderful? Fantastic. We have been able to break it down. So sometimes it takes all patience. Okay? So now, finally, when we see the integral of cos 4x plus 1 all over cotangent of x minus tangent of x dx, our answer is nothing but negative 1 over 8, where cos 4x plus c. Wow, beautiful. So that is what we have. Well, friends, this will bring us to the finals, that we're able to do the question with ease. So we can do a quick recap for us to be able to, ascertain how we get to the final point. Okay, right now, let's go up. So right from the scratch, there's a question we have. So in my suggestive analysis, when I saw cos 4x plus 1, it gave me a certain hint. Okay, so I said cos 2 theta over the years is 2 cos squared theta minus 1. Or or, okay, let me add it to it. You see, or, or, or 1 minus 2 sine squared theta. So it's either 2 cos squared by 2 cos squared theta minus 1, or 1 minus 2 sine squared 2 minus 2 sine squared theta. So that analogy, okay, here I give a little bit of a proof of why it is so, which doesn't form part of the equation at all. So now we say from the integral given, we have cos 4x plus 1 as the numerator. So therefore, since cos 2x minus 1, cos 2x gives us 2 cos squared minus 1. In analogous sense, we say cos 4x will give us 2 cos squared 2x minus 1. So we came back here and we substituted this into this equation, and after that, after everything, we neutralize the equation to be this. Okay, we got to a point that we also looked at the tan, the denominator, the cot x minus tan x. So we know cotangent of x is 1 over tan, and that of tan was tan there. So we multiply through by this tan x, okay, tan x. So then that gave us 1 minus tan squared x as a denominator. Then our numerator became 2 cos 2x tan x dx. And we know that 1 minus tan squared x will give us x squared. That wasn't going to help us at all. So then we thought of this. Why don't we expand the cotangent, which we always know it to be cos x over sine x, and our tangent is always sine minus cos x. Then, since we have cos and sine together, we decided to multiply it by the product of sine and cos. Because when you divide sine cos x by sine cos x, we get 1. So it's just like multiplying this one by 1, and we're able to break the equation down to this. Okay, to this expression. Now, we, by observation, realize that cos squared x minus sine squared x give us cos 2x. Therefore, replacing it back, we had cos, this one from here, after substitution, okay, we had cos 2x. Okay, now here at the top, when we separated 2 sine x cos x by factorization, we also realized that sine 2x is given as 2 sine x cos x. So we substituted that in here. Then we realized that cos squared x, okay, cos squared 2x over cos 2x will cancel to give us 1. 2x will give us cos 2x. Okay, so then we're left with cos 2x and sine 2x dx. Now, we knew that with the double angle formulas, we have sine 2x, our equation is 2 sine 2x is equal to 2 sine x cos x. So in the same way, if we had sine 4x, that would be 2 sine 2x cos 2x. And when we made sine 2x cos 2x the subject, since we have it in our equation, and by substitution, we got half sine 4x dx. And upon integration, this is what we had. Well, you can do that by also using the use substitution to test the integral. If you don't know that, if you integrate sine 4x, will give us minus 1 over 4 cos 4x. Then you can use substitution, but that is it. So the minus 1 over 4 multiplied by the half gives us 1 over 8, and hence that is what we are able to come out with. Well, friends, this is where the entertainment will come to an end with. It's been so nice having you on board, and without you being on board, the captain cannot propel. Fantastic. Please subscribe as you do all the time, and also share it with your friends. And if you like, maybe you can also give us a like on the video, so that will help us to do more. Have a lovely day and continue to stay blessed. And wear your mask. COVID is real. Bye.